So now what we're going to do in this lecture is we're going to take these rules and assume they're true. We'll almost think of these as axioms. So axioms are things that, now we've seen them with laws of sets, they're axioms. We've seen them with axioms of real numbers. These are just things that we assume to be true. You don't quite prove them. And take this as a foundation and say that if these rules are true, can we assign meaning to zero powers, negative powers, fractional powers, and beyond. So we're going to take these as true now. You see, the issue is 8 to the 0, negative powers and fractional powers don't make sense in terms of, 3 to the power 4 means 3 by 3 by 3 by 3. What does it mean to multiply 3 together 0 times? What does it mean to multiply 4 together minus 7 times? What does it mean to multiply 5 together a half times? This kind of thing. Now you can, in time, gain some intuition for these, but realistically, we're just using rules and assigning meanings consistent with the rules or the axioms. Okay, so yeah, so this is what we're talking about. Now there's further ones here. So root 2, you may or may not remember this from school, but root 2 is not a fraction. I think actually we did this in the very first lecture. So this one's a bit harder, and 1 plus I here is a complex number. Now you'll probably never need complex numbers unless you do some heavy graphics work, but 1 plus I is not even a real number. It's a complex number, but you can assign meanings to these, but we'll actually just go up to here. Okay, so we're going to assign meanings to these that are consistent with our little axioms. So note that every number is an integer. So say 7, that's an integer, remember, is a whole number. So natural numbers, in this context anyway, are 1, 2, 3, so on and so forth. And integers we might write as ... minus 2, minus 1, 0, 1, 2, ... So all the whole numbers. So everything in here is in here, and everything in here is a fraction, because for example minus 11 is minus 11 over 1. So what we'll do is we'll construct definitions for zero, negative, and fractions that extend the definition for natural numbers. Now what that means is, am I even going to do that? I don't know. And make the laws of indices consistent. In other words, we should choose a definition for fractional powers, and that we're also going to probably just specify positive bases, because you can get into trouble with negative bases, which we may or may not see, and fractional powers, so that the following makes sense. A to the m by a to the n is equal to a to the power of n plus n. And I think the repeated power one is probably more important than the division one. A to the m all to the power of n is equal to a to the power of m by n. We may or may not need a to the m divided by a to the n is equal to, I think we mightn't even need this. Well, we'll see. We will. Okay, so if it makes sense for fractions, it makes sense for everything. Okay, so what we're going to do is we're going to start with a number, say 7 cubed, for argument's sake, and multiply it by 7 to the power of 0. So what does it mean to multiply 7 together 0 times? Now you can try and come up with a meaning, but we want something that's consistent with this. So rather than coming up with the meaning and checking is it consistent, we'll force it to be consistent with these and find out what it has to be. Now there could still be contradictions, because there could be contradictions between these, and that's another day's work, but it doesn't occur here, so don't worry about it. So using the rule that says if you multiply like powers, you add the powers. And what's 3 plus 0? Well, that's a real number axiom. Any number plus 0 is itself. So the question becomes, what is 7 to the 0? So what number times 7 to the 3 gives the same thing? And it can only be the number 1. Now you could, and we'll do a little bit of algebra to find out, show just it couldn't be anything else. Maybe I'll just do it on this one. So this number, let's call it x, it's the unknown. So 7 cubed multiplied by what gives you 7 cubed. You can say it's just obviously 1, and that's probably what I would normally do, but let's go a bit more. So you're trying to find out x is, you need to get rid of this multiplied by 7 cubed. what is the inverse of multiplying by 7 cubed, dividing by 7 cubed? Do it to both sides. You'll get that x is equal to 7 cubed divided by 7 cubed, and what's any number divided by itself? 1. So this number can't be anything but 1. So we find that 7 to the power of 0 must be 1. Now we're going to, as I said, we're going to stay away from negative numbers, but I think this one works for anything. But we'll just deal with strictly positive numbers here. So we have that, I'll probably use a different color because it's slightly different. It's not a rule, it's a definition. A to the power, anything to the power of 0 is equal to 1. You don't have to remember that. We will actually have a way of making sense of this, which we'll do, but if you want, it's just a definition there. Right, so let's have a look at this one. And this, okay, so suppose that a and b are positive real numbers such that a is equal to b cubed. Simplify this. So first we'll replace a equal to b cubed. So a is b cubed, and that's squared, divided by b squared, b cubed. So we're going to go with the rules here. Now okay. So repeated powers multiply by the power, repeated powers multiply the powers. So b to the power 3 to the power 2 is b to the power 3 by 2, which is 6. And b to the power 2 by 3 is also b to the power of 6. Now, if we're kind of using our heads a little bit here, we'll simply say that this is a number divided by itself, which is 1. But let's go a different direction. Let's say use that division of like powers means subtraction. So you got b to the power 6 minus 6, which is equal to b, sorry about the 6's and the b's. So change, it's just for me, change from b and 6 because they look the same. 6 minus 6 is 0, and b to the 0 we know is 1. Okay. What about negative powers? Can we make sense of these? So what we're going to do is we're going to multiply together 3 to the power of 8 and 3 to the power of minus 8. Okay. Now, whatever we don't know what 3 to the minus 8 means, but we're kind of forced it to have the property that if you multiply it by a power of 3, you'll add the powers. So this is 3 to the power of 8 plus minus 8. And 8 plus minus 8 is 0. And 3 to the power of 0 is equal to 1. Now the question becomes, what number do you multiply by 3 to the 8 to get 1? Now I could just write it down to say that the number you multiply by 3 to the 8 to get 1 would be 1 over 3 to the 8, but we'll actually prove it here. We'll do some algebra. So we'll do it up here. So 3 to the 8 times what number? So we'll call this number x is equal to 1. You want to get x on its own. It's multiplied by 3 to the 8. So divide both sides by 3 to the 8, and you get that x is equal to 1. So if you divide it on the left-hand side, you'll get rid of the multiplication, and 1 divided by 3 to the 8 is like this. So 3 to the minus 8 is 1 over 3 to the 8. So this is a definition here now for, again, I'm going to take or to be a to be positive, strictly positive, just to be ultra safe. So we get a to the power, so negative powers actually means division, and we'll get a bit more sense of that on the next page, I think. So negative powers means division. Now you can say negative power means 1 over, but to me really you should say negative power means division. So so I could write down something over here in terms of the notation of the previous chapter, that multiplying by a to the power of minus n is the same as dividing by a to the n. So multiplying by a to the minus n is the same as dividing by a to the n. So that kind of takes away the 1 over business. Yeah. So positive powers are multiplying. We know that, like 7 cubes means 7 multiplied by 7 multiplied by 7. But negative powers are dividing. So like 7 to the power of minus 3 means dividing by 7 3 times. Okay. So we'll have a little look here. So we're going to go at this totally with the rules. So I'm going to write in equals. I mean, this is equal to. So let's write it all as a power of 10. 100 is 10 by 10. And then multiply like powers, you add the powers, and minus 1 plus 2 is equal to 1. And then the question is, what does this tell you? Well, 10 to the minus 1 takes 1, what's 10 to the 1 is 10. So multiplying by 10 to the minus 1, this is just like this actually, is dividing by 10. So look, what do you have to do to 100 to turn into 10? You divide by 10. So it tells you that x to the minus 1 is 1 over x, or moreover, multiplying by x to the minus 1 is the same function as dividing by x. So multiplying by 10 to the minus 1 is the same as dividing by 10. Yeah, okay. So this thing tells us a few things. If you want to divide by x, you can multiply by x to the minus 1. We said that. We already said if you want to divide by x, multiply by 1 over x. And then it's just all consistent because from the definition we have, so we'll call those things axioms, and then these are going to be definitions that are consistent with the axioms. So we also have x to the minus 1 means 1 over x to the 1 next to 1 means that. There's actually another way of explaining why 0 powers are 1 that might also shed light on how we do negative powers. So this is just, if you want to kind of understand on a deeper level, this is probably a good idea. So we start with the fact that multiplying by 1 doesn't change anything. So given number 8, you can write, say, 8 to the power of 1 as 8 multiplied by 1. I think that's what I'm trying to say there, I think. And maybe actually I want to write it as 1 multiplied by 8. Obviously they're the same thing, so I can write an equals. So what we can do with multiplying is you can think of your base when you're multiplying is just 1. When I say base, I mean where you're starting with. Now when you're adding, you start at 0. When you're multiplying, you start at 1. So I'll show you how this kind of will work out. So say if I just work with 8 squared. So that is 1. So I'm going to say starting at 1, multiplied by 8, multiplied by 8. 8 cubed is 1 multiplied by 8, multiplied by 8, multiplied by 8. And then say 8 to the 4 is 1 multiplied by 8, multiplied by 8, multiplied by 8, multiplied by 8. So, and look what you're getting here. On the left-hand side, you're increasing the powers, or you can think of positive powers maybe. And here, every time, you're multiplying by 8. So multiplying by 8, when you've got a power of 8, is the same as adding the power. So multiplying is adding positive powers. So to increase powers, you multiply by 8. Now coming from the other direction. So say you go from 8 to the 4. What brings you to 8 to the 3 is going to be a question in a second. What brings you to 8 squared? And then what brings you to 8 to the 1? So what is the inverse? Well, it's dividing. So to go from here to here, you do dividing by 8. To go from here to here, you do dividing by 8. To go from here to here, you do dividing by 8. So what we're going to do then is, if you want to go from 8 to the 1 down to 8 to the 0, you're going to divide by 8 a final time. So we have 8 to the 1 is equal to 1 multiplied by 8. That's up there. And then if you want to reduce the power by 1 again, well, what you have to do is, look what dividing does is reduces the powers. But if you divide this by 8, this is just 8. 8 divided by 8 is 1. So this is kind of another way. And then you can keep on going. I think we're going to see that down here. We may as well do it here. So if you want to keep on going, you can go from 8 to the 0, which is equal to 1. Excuse me, which is equal to 8 to the 0 is 1, yeah. And then you can go, if you divide by 8 again, you get 1 over 8, which is the same as dividing. Look, reduces the power. Go again. Now, if you divide, you got 1 divided by 8, and then divide by 8 again, you're dividing by 8 twice. You're dividing by 8 squared. And this is 8 to the minus 2. There should be an arrow. And then you can just keep this playing this game. So you see that really negative powers is division. So what have I got here? How do I get from here to here? I divide by 8. How do I get from here to here? I divide by 8. How do I get from here to here? I divide by 8. Okay. If you go back on the idea that when you multiply, you always start at 1, you could think of 8 to the 0 because it's powers, it's about multiplication. You start at 1 and you do nothing. So this is called an empty product. When you multiply no things together, you get 1. So you get mad examples. So let S be the set of all students who are at least 10 feet tall. There's none of them. Take their ages and multiply them all together, you get 1. So this is some kind of bizarre stuff, right? But anyway, the important thing for you, if you're a bit worried by that, is, look, it's right here. But I like you to think that negative powers means division. What about fractional powers? So what we'll do with 9 to the power of a half is we will, there's 2 ways, I'm actually going to do this 2 ways if I can. Yeah, so for me, there's probably 2 ways of thinking about this. So I like, there's a slight disconnect as I'll talk about. So I'll use the first law. And then we'll get what I'm getting at in a second. So multiply together, like powers, you add the powers. Okay. Oh crap, forgot to add them. Half plus a half, half plus a half is 1. 9 to the power of 1 is equal to 9. So the alternative thing here, by the way, is that this is 9 to the half multiplied by itself, so that means squaring. And I could go from here to here directly because repeated powers, you multiply the powers. So there's 2 options here. But anyway, 9 to the half squared is equal to 9. So the question is, what number squared gives you 9? Now, if you give me the answer 3, that's correct, but I want to be a bit more general. So what's a number that you square and gets back to the original number? So take 16. How do you get the number that squares 16? You do the square root. So what we're talking about here is, here certainly, is 9 to the power of a half is equal to the square root of 9. Now, one thing that we often don't write, but we could, is this one is always, this is the second root of 9. This is written like this. So let me just show you this. So where are we? The second root of 9 is the same as the square root of 9 is 3. Right, so we see, yeah, so to keep things easy for us, we'll only consider fractional powers of positive real numbers. And I've actually been specifying this the whole time. So you get into danger if you want to find minus 1 to the half, you get in danger. So we've got a definition here, certainly just for the power of a half. A to the power of a half means the square root of a. And that's not here, but you've got an open book. I would encourage you to add 8 to the power of a half is equal to the square root of a. It does fit into this because what I just wrote there, that the square root is the second root. Okay. What about 5 to the power of 1/6? So again, that doesn't really make sense. What's 5 multiplied together is 6 times. Now, it's not 1/6 by 5. If you do it like that, it's not going to be consistent with the axioms. It's a waste of time. We're trying to assign meaning to this that is consistent with the axioms. So we'll do a similar story. We'll do the third, the 6th power. And then the third rule says repeated powers, you multiply the powers. 6 by 6 by definition is 1. So I'm going to present this kind of a little bit in a funny way. So what number power of 6 gives you 5? Well, you apply the, I don't know if I think we did, so the inverse of the power of 6 function is the 6th root. And this is the definition of this 6th root thing. So the 6th root of 5 is a number that you must take to the power of 6 to give you 5. That's a definition. So 5 to the power of 1/6 is the number, when brought to the power of 6, this is known as the 6th root, which we write it like this. And extends, it's like, instead of the square root, the 6th root. So again, we've got this is a general thing. And we've got a definition here, And again, it's in the definitions there. A to the power 1 over n is the nth root of a. Okay, what about 6 to the power 3/5? So what we're going to do is the following. 6 to the power 3/5, just hear what you said, 3/5. 6 to the power 3 by 1/5. And then where do powers multiplied together come from? They come from repeated powers. So this is 6 to the power 3 all to the power of 1/5. And therefore this is 6 cubed, and then power of 1/5 means the fifth root. So you can see this as the cube and this is the fifth root. And a subtlety is we can change the order of multiplication here. And so 6 to the power of 3/5 is also equal to, if I do the fifth first and then the cube, 6 to the power of 1/5 all cubed, and this is the fifth root. Oh, my head. Fifth root of 6 all cubed. Now what this actually suggests is something a bit fancier. So if we take two functions, so let's take, I can't remember the notation we would have used. So take p of x to be the function x to the power of p. That's a really bad notation. Terrible notation. So x to the power of b, say. So b is just some number. It's going to be a fraction. Actually, it has to be a natural number, I think. And r of x equal to the 8th root of x. So a and b will be natural numbers. Okay, so for example, here cubing and fifth rooting. So a power function and a root function. What this shows, these have to be the same thing. And so if you do power after root is the same as root after power in terms of composition. So let's just see a little example of that. So I'll take a number 10, do the power of q, power of 3, and then let's say the fourth root. We get 5.6213. Do it the other way around. Was it cubed? Well, let me try again, sorry. So if you do 10 cubed first, and then do the fourth root of that, 5.6. Alternatively, start with 10 and do the fourth root, sorry, and then cube it. You get the same thing. Okay, so it's just something feeding into the functions. So we've got a final definition here. So a to the power of m over n, you can think of it either as you do the power first and then the root, or you can do the root first and then the power. I think often, maybe sometimes this one is easier. Okay. So one of the things that happens to us now is we get a little bit of trouble with Pemdas. So these kind of things. So this one, ab to the n, means a, b multiplied together n times has to work like this. You can show that this works even when the power is not a natural number. So see all these two here, these also hold. So these are like mini theorems. Let's call them facts, keep it simple. So those things still work if p is a fraction, no longer just a whole number. All right. Now if you write this is wrong. So be aware of this. 2x all squared means 2x by 2x. And if you do 2x by 2x, you get 4x squared. So 2x squared, you do the power first by Pemdas. Look, exponent before multiplication division. So I do the power first, x by x, and this is not the same as 4x squared. So this is the other one people have difficulty with. So this is not this. So if you 5x squared cubed, this is 5x squared, 5x squared, 5x squared, 5 by 5 by 5, x squared by x squared by x squared. It works like that. So you have to be a little bit more careful with these. And I said these facts about powers are all collected here. Lovely. So I think we're going to do two little examples if I have time. No, I'm going to put them in the next video.